Good evening, guys. We'll start in a bit. Let's give it 5 minutes so that people can join, and we'll hop straight on into it. All right, it looks like we won't have a live turnout, but start anyway. So for today's talk, we have brought one of the biggest fintech startups in Egypt and the Middle East and North Africa as well. We have Mustafa, who is their strategy and business intelligence VP. We have Ahmed Mansour and Ahmed Sin, who are both senior data scientists at Halan, and they're us through, as we've advertised, they're going to talk us through data science, startups versus corporate, how to get into data science and the field. So without further ado, Mustafa on live, and he's going to introduce the team work.
Hello, everyone. First of all, pleasure to be here. I hope this talk is going to be fruitful for you guys. I'm going to start this off with a quick introduction about myself, about Halen, about the team. And from there, I'll be giving you a brief about my journey in startups in Egypt and the Middle East. I'm going to give you also a brief the role of the data science team in growing a startup in different stages, whether at launch phase, whether at growth phase, and at the phase where we decide to pivot our products to be more relevant and to bring in more value to the ecosystem that we're working on. So first of all, my name is Mustafa. I'm currently VP of Growth and Strategy in Halan. I've been working in Halan for the past 3 years as part of its initial founding team. Before that, I was head of growth and planning in 𝐃𝐚𝐭𝐞. I don't know if you guys know about 𝐃𝐚𝐭𝐞, but it is a ride-hailing, the very ride-hailing company in the Middle East that was later on acquired by Uber. I've kick-started my journey there as a supply manager for performance enhancement, and then I handled supply growth across Egypt, and then later on I started handling both supply and demand growth in Egypt, where I had so much contact with the base camp growth team, or the data science team, or the BI team, the marketplace team in Dubai. And then I went on part of the founding team in Halan, the very first team that succeeded the Halan's three co-founders. I started off there as head of marketplace and business intelligence, where my main job was back then building the data infrastructure, making sure that we collect the right data points, making sure that we collect all the data that we need in order for us to understand the business more, grow the business more. And I then started hiring the growth team, the data science team, and enlarging the BI team, and we'll come to that point to discuss more about it. Before that, I was basically an engineer. I graduated from environmental engineering in Cairo University, and I worked as an engineer for quite some time. But then I decided my passion is more towards data, and my passion is more towards the impact of how can you make better decisions based on numbers, based on insights, and based on what is beyond what the product is telling you. This is exactly the point when I sort of found my passion regarding startups and regarding how can startups disrupt a lot of services and products in the ecosystem of the MENA region for it to basically simplify people's lives and bring in more value to what we do and make basically everything easier and more affordable and provided with better quality for sure. So back to the data science topic and how does data science serve our startup today. I would like to bring in an example where I put in a comparison between 𝐃𝐚𝐭𝐞 and Uber. Okay, in 𝐃𝐚𝐭𝐞 we had this central team in data science that was basically based in Dubai, where the data science team in Dubai basically served multiple countries, but with a regional focus, a regional sort of focus. At that point in time, 𝐃𝐚𝐭𝐞 had a very strong market share war with Uber, where the management at that point decided that we want to bring in maximum growth. We want to make sure that our services are better, our fleet is bigger, our fleet is more satisfied, our cost is more engaged. And for that to happen, we had to be basically competing with one hell of a technology provider, being Uber at that point in time. I remember back then a topic that we used to discuss hugely in the management of 𝐃𝐚𝐭𝐞 Egypt, that we were missing a lot of insights. We were missing a lot of models that we believe could have in a way or another facilitated the growth of the business time and brought on a lot of value that basic analysis and basic business intelligence wouldn't have been able to bring. Versus what we've been seeing in Halan, where it was a decision to bring in a management, a data science team very early on into the journey, and to utilize the data science mindset in bringing in the most and the maximum value when it comes to the kind of data that we collect, the kind of data that we aggregate, and the kind of data that we pull on maximum thought process and maximum depth of analysis within. I've been working closely with the data science team in 𝐃𝐚𝐭𝐞, and I've had the pleasure to lead the data science team in Halan, and I'm telling you, the impact of a data scientist on the business is marvelous. We have multiple examples where the data science is bringing a lot of value in Halan. But before I go into, let me give you a brief about what Halan does. So basically, Halan started off as a ride-hailing company for the underserved community in Egypt, which basically is almost 90% of the population. So we decided that maybe 𝐃𝐚𝐭𝐞 and Uber are very big players in Egypt, but they're targeting only 10% of the population, which basically is the 10% who can afford to have a ride that is $2.50 and above daily. versus an average commute that takes almost like 30 to 40 cents in Egypt, which basically puts you in a segment that is more distinct of definitely less volume than the segment that we're targeting. So we said, no, we don't want to be targeting the niche. We want to be targeting the 90% of the population. We started off in ride hailing, and then we went on to logistics, where we acted as a delivery fleet provider solution for F&B restaurants, for pharmacies, for malls, for post services, and a lot of things. And then with the COVID-19, and I think it gave us all one hell of a lesson. We started to shift into a pivot to cater for the kind of trend was there at that point, or and that is still there today, which basically is the fintech world, including microfinance, consumer lending, nano loans, e-payments, cash collection, loan collection, and stuff like that. So we an online commerce portal, which at a point in time did not make so much sense if the payment was provided in cash, or the payment was asked in cash. So we then started to say, no, for us to cater for a better growth trend, we needed to do commerce through consumer financing, where the customer basically does not have to pay in cash, but would rather pay on an installment basis. And then we kicked off our e-payments portal, where people were able to top up their wallet and then start paying their bills, their taxes, payments for friends, and stuff like that. And then we kicked off another exercise that do with microfinance, where people and start to borrow money and then give back this money on an installment basis, etc., etc. And we have now a base that is combined more than a million customer on both ends of the microfinance and the super app platform. And for that kind of very big data set, or let's say consumer base, data science comes as one very key and critical team to bring in value when it comes to driving growth, when it comes to putting in more efficiencies, when it comes to fighting fraud, when it comes to automation of a lot of processes, and when it comes to making sure that all teams are seeing the kind of data that is complex enough, deep enough, in the simple manner that would allow people to make very, very strong decisions, or very data informed decisions. And I started hiring my data science Halan. Luckily enough, we're pleased to have our two data scientists here to walk you through the process, walk you through their journeys, and how they started it, how is it going today, and what are their aspirations for the future. But before I give the floor to them, I'd like to just like walk you through a set of projects that they're working on. They've been working on a set of projects that have brought a lot of value into organization. So and our examples are not limited to fraud fighting, demand prediction, demand and supply prediction, the demand and supply placement prediction, promo code generation. In microfinance, it had to do with default prediction of loans. It had to do with social network analysis. In logistics, it had to do with fleet placement solutions. In commerce, it had to do with pricing, bundling, and a lot of stuff. I wouldn't be wanting to talk on their behalf, but again, we're lucky enough to have them both here to give us a brief about their journey and a brief about what they do in Halan. I hope you guys enjoyed the talk. I'm pleasure to take any questions after that call, and from there I give that to Ibrahim.
All right, thank you, Mustafa, for the great insights. I'm pretty sure everybody wants to get onto the data science part now. So without further ado, I give you Ahmed Mansour, senior data scientist at Halen. Ahmed Mansour, you have the floor.
Hello, everyone. My name is Ahmed Mansour. I am a senior data scientist at Halan Technologies. And I'm here to talk you through about what is data science, how to get into the field, what are the blockers that are currently available, why join data science in the first place instead of any other developer or a technology career. So let me share with you the slides first. All right. So first of all, a little background about myself. I've graduated from the German University in Cairo. I have a bachelor's degree in information engineering technology back in June 2012. After that, I got a master's degree in data science and analytics from the University of Warwick in the United Kingdom in July 2017. In the meantime, in this gap in between, I worked as a technical analyst at Dell EMC for 2 years, which was basically we used to solve the technical problems of the Dell EMC customers from an analytics perspective. And then after that, I transitioned to a master's in data science because honestly, in when back when I was in the German university in my bachelor's, we had some rigorous theoretical background in mathematics and in computer science as well, because the field I was in was a mix of both. So we had to be able to code really well and at the same time know the theoretical foundations of math and computer science as well. So, and I knew back then that data science was a discipline that has both of them in its mixture. So I went into I applied for the master's degree in Warwick. And as I was doing my master's degree, I got an internship as a data scientist in a company called Nimbus Maps, where they used to do data science and analytics on real estate projects, which is actually a field that is currently ramping up, which is data science and analytics in the real estate business. After that, I graduated and I came back to Egypt and I joined Vodafone as a data scientist for 2 years. I worked there at the customer value management department in the marketing segment, where we used to do use cases and projects that would enrich the customer's user experience in using Vodafone. Um, we did projects related to predictions of recharges, predictions of churn, of telco users, as well as projects that would ultimately enhance the value taken from the customer himself back to Vodafone. And then I transitioned to the startup scene. I joined Halan in September 2019, and I've been there ever since. We've worked on many projects during that time, including and not limited to fraud detection, supply placement, supply analysis, demand analysis. We worked as well on demand prediction, and we worked in the financial sector. We worked on loan defaulting. We worked on clustering of our user base and our sales representative base, and many others. So this was just a brief introduction, and let's get forward to why data science. So first of all, I'm sure some of you might have seen this picture before, that data is the new oil at the moment. So there is currently a vast proliferation of data that has happened in the past 5 to 6 years. And this was probably appeared due to the abundance of data sources that became true at the moment, from social network platforms to mobile devices to sensors everywhere to video cam streamings. So the content generating devices has vastly increased over the past 5 years. allowing for the generation of a huge amount of data that currently most companies want to utilize and want to get on board with. Furthermore, one of the reasons why data science and the data career itself kicked off that steep was because the compute power and the processing power of computers nowadays and devices has dramatically increased. So at the moment, most companies are now able to parse and process vast amounts of data in very short periods of time, in contrast to what was there maybe 7 or 8 years ago, or 10 years ago maybe, where it wasn't that often. Another thing that could be a huge motivation in working in data is that companies have now came to realize that they need a new differentiator. They need a differentiator to differentiate them between themselves and their competitors. And they've realized that knowing their customer and knowing their products by heart is key into actually having this differentiator. And hence, many companies have started seeking out data scientists in order to actually try to understand and segment their customers more. And I'm talking from a very high level here, because knowing your customer entails maybe many projects and many pipelines, so that you can be able to actually say, okay, I know my customer by heart, and I know exactly what he wants, when he wants it, and how he wants it. So those, from my own point of view, are the reasons why data science has kicked off that fast the past 5 years. Furthermore, as you can see, this is a graph showing the data science queries in Google search engine, where you can see that the proportion of data science searches compared to 2010, for example, has increased dramatically until late 2019. And here I'm talking, this is the proportion of the maximum amount of searches versus each search. So you can see here that the relative amount of search in keyword data science has increased dramatically, whether it's by students, by companies, by employers, by employees looking for jobs, by industry professionals looking to switch careers to the role of data scientist. But you can see here how this career and this role has jumped sky high from 2015 up to today. Furthermore, working as a data scientist is an extremely rewarding job that constantly challenges your mind, and because essentially a data scientist is a problem solver. So eventually a business guy comes to you with a problem that he has in his company and he needs to solve using data. And it's up to you as a data scientist to formulate this problem, work on it, produce results, and communicate it to the business stakeholders as clearly as you possibly can. Furthermore, this is from LinkedIn. There has been a 29% increase in demand on a data scientist role year over year since 2013, versus only 14% increase in supply, which is us, which is the actual students and employees of data science. And actually, there was a 334% increase in the demand in data science from 2013 until 2020. So you can see here there is a huge gap between the supply and demand when it comes to a data scientist role. Companies are aggressively searching for data scientists that can help them make sense out of their vast amounts of data, while there is not so much supply from universities and from online courses and online platforms that produce actual data scientists. And furthermore, in most countries, the pay of a data scientist role is much higher than the average pay grade in technology careers, to be exact. So I've been talking about data science, but let's talk what is actually data science. So I've brought in a definition from three different sources that essentially say data science is the art of uncovering actionable insights from disconnected pieces of information, learning from data, and communicating its uncertainty, making sense of structured and unstructured data. So this shows us that actually there is no consensus exactly data science is and what exactly does a data scientist do. Because at this point, they all revolve around making sense of data. But making sense of data actually is a huge process and might require multiple teams and disciplines to be able to actually do that. However, what I want to focus on here is that data science, no, there's absolutely nowhere here that says data science is predictive analytics, or it is predicting the future, or is it just using machine learning to predict something. Data science is much more than this. Data science is a discipline that takes into consideration data analysis, data analytics, and in the end, it uses data mining and utilizes machine learning to do the predictive task. So actually, a data scientist is not only focused on how to predict churn or how to predict the stock market. Data science actually is much more bigger than that. As part of your job and your role as a data scientist, you need to analyze, you need to bring in the various data sources, you need to understand descriptively what the data says. Actually, you would find that maybe 50 to 60% of the tasks that are given to you can only be solved through descriptive means without even having to use machine learning to formulate a predictive strategy. And this is a very common pitfall here, that when employers look for data scientists, and when actually people want to transition to work in data science, they think that it's just predicting something or solving a problem by predicting what the customer wants or what the customer will use in the future. This is not the case. Yes, machine learning is a part of your skill set and a part of the tools available to you that you can use to solve your tasks. However, it's not at all the only thing that data science does. So data science is a multidisciplinary field. So as you can see here, it combines multiple fields, mainly computer science and math. So in my own experience, I believe these two are key if anyone wants to transition to a data science role. You would need definitely math and statistics for the theoretical knowledge and how to actually make sense of data, whether through statistical means or through predictive means by utilizing optimization, whether linear or nonlinear, more advanced statistical methods that would help you model the data and model its distribution, for example. And at the same time, you would definitely need computer science, because actually, at the end of the day, a data scientist is inherently a developer. So actually, you will write code that does the job. So I'm not saying that a data scientist has to be a super developer, because for a data scientist, development is a means to an end, or coding is a means to an end. So you don't have to be able to code production grade coding. However, you need to know your way around high-level languages such as Python, so that actually you would be able to solve the task at hand, regardless of whether it's predictive or descriptive. Furthermore, you would also need business or domain expertise in the domain that you're working on. But honestly, I believe that this is not a key thing that you should have while actually applying for a job, because this will come while working. No one, or very few data scientists have domain knowledge or domain expertise in the area that they're going to work in, because a data scientist can change from a company to company, and each company has its own domain. So now I'll briefly walk you through data science in real life. So the differences between expectations from the academia and from the competitions to reality. So currently, the data science workflow in general consists of a few key steps. So a business guy comes to you with a problem and tells you, for example, okay, I have a high rate of churn in my company, and I want to know why. That's number one. And number two, I want to be able to identify the people who will churn in advance so that I can try to lure them back or try to give them extra value, preventing them from actually churning. So as a data scientist, along with the business, you define the problem. You check if there is data and available resources that would help you as a data scientist solve the problem. You estimate the return on investment, whether it's worth your effort and it's actually valuable for the business. You classify the problem from a data science perspective. Is it descriptive? Is it predictive? Is it prescriptive? And for example, if it's descriptive, then you start going through your normal statistical analysis and visualizations. And if it's predictive, you begin doing some more effort, which is actually defining what the model will learn. And this takes a huge amount of effort to actually get the target variable right. What do I actually want? So in this case, in the churn, it's not enough to just say, okay, I will check for people who are churning. You need to define what a churn is. So is it the people who became inactive in my service in the past week, or they have been inactive for 2 weeks, or maybe your service has an activation and deactivation cycle, like Nets, for example. So you need to work with the business rigorously so that you would able to define these metrics that the model will learn from. And then you do feature engineering where you create features that the model looks at in order to find the relation between the data and what you're actually trying to make the model learn. This is real world data science, and it takes on average around 3 months to finish an actual data science project. However, in the academia and competitions, like 𝐃𝐚𝐭 competitions, for example, they abstract most of the things for you, and they give you a data set that is mostly cleaned, that has a label. Your business problem is well understood. You don't have to estimate an ROI. You don't have to check for feasibility of data because data is already there. You don't have to classify the problem because, well, actually, you have an objective, which is predicting something, for example, in the competitions or in the academia. So most of these things are abstracted from you, and as soon as you graduate and you land the data science role, it suddenly hits you that, okay, things are not as easy as I thought they are. Because also in the data sets and data sources that they give you in competitions, mostly the problem is solvable and someone has solved it before and it's not too hard. However, in real life, you might find yourself working for like a month on a project and then suddenly realize this is not going to work, or the accuracy is not going to be as good as I thought it would be, or this problem is infeasible. I cannot solve it using machine learning. I need something else. So this is a huge takeaway you need to check when actually trying to match expectations versus reality, because it's a bit different in the real world. Another thing is that because data science is ambiguous and there is no well-defined job description for data scientist, you end up finding that an applicant, which is yourself or me or anyone working in the data science field, says, I'm interested in doing machine learning on massive data sets, so I'll apply for a data scientist. While many businesses nowadays think of data scientists as automation engineers. So they just say, I need someone who can build a dashboard or a tool from Excel workbooks. So I'll hire a data scientist. So here it comes to the expectation of what you think you will be doing and what the business thinks you will be doing. So when applying for a data science role, you need to make sure 100% that the job description meets your expectations and that the business who is actually trying to hire you knows exactly what he is hiring for. so that you won't go there with some very high expectations and you find out that the job is not entirely what you thought it was. And this exact example happens a lot in the field. The last thing I'm going to talk about before I hand over is, from my experience, the difference between working as a data scientist in corporates versus startups. So I've had the opportunity and the pleasure to work in both fields, whether I worked for Vodafone, which is a huge multinational company, and as a startup from the ground up, where we were only 20 to 30 employees, and now we are more than 100 in Halan. So when you work as a data scientist in corporate, as with any job in a corporate environment, it will have a well-defined scope. You know exactly your thresholds as a data scientist. You know exactly what you should do. The data is there because enterprise companies know how to collect data, and they've been collecting it for many, many years. You'll find that their warehouse and their data infrastructure and BI is mature, and it's well defined and well orchestrated. So it's going to be much easier to actually find the data you are looking for. And also, and here where, and I think this is very important, you will have dedicated teams serving the data for you, which is the data engineers and the data ingestion engineers. So you'll find that there are 4 or 5 teams maybe serving data purposes, whether they are helping you in getting the data you need if the warehouse is too large, or people who are actually enhancing the warehouse and enhancing the data experience. So this can make your life much easier. However, the problems with corporates, in my own experience, is that usually corporates, especially if they're still exploring what data science is, they will bring you in as an experiment. So you're not going to be a core function in the company. Probably they will be doing stuff and they want to see if you can do it better. So for all intents and purposes, this can be good, but this can also be bad. It depends on how you look at it. Also, you probably in a corporate, you will lose the edge of open source, because most corporates, they don't use open source. They don't like open source because it's open code. So usually they will have enterprise tools with huge security constraints that will actually elongate your project pipeline by magnitudes of power. So these two are for me are huge drawbacks in working in corporates. In startups, however, it's actually the entire opposite. So the startups has a super fast project lifecycle because everything is there on the spot. You have all the open source tools that you would dream of. You can use anything from the internet. It has a very good learning curve because you will have to stretch beyond your scope a bit, not like the corporates where you have a very well-defined scope of work, but in startups, they thrive on the idea of, yes, you are a data scientist, but you can do so much more. So you end up learning a lot from so many disciplines that gives you a wider view on what the data infrastructure is and what the data lifecycle is from the start, from the data ingestion until actually you model something and produce the output. However, the cons of a startup is that people might see that this scope thing is not defined as a bad thing. Some people like to have a very, very well-defined scope and not tiptoe past their thresholds. There won't be dedicated teams to serve you data. Probably you will have to go fetch the data yourself from multiple sources. So this also can be a bad and a good thing. A good thing for people who would want to say, okay, I want to explore data engineering. I want to actually have this scratch the surface knowledge on how to fetch data from different data sources. But on the other hand, some people can say, okay, I'm a data scientist. I already have enough on my plate. I don't need to actually learn a new thing and try to fetch data myself from different data sources. And also, a bad thing in startups is that it ends up having some spaghetti structures. So teams tend to overlap on each other. There tends to have some tiptoeing on scopes between people. Sometimes if you want something, you won't quite know who to call or who to reach out to. I'm not saying this is something in all startups, but it's a common thing, because an essence of a startup is that it's actually not very structured, and this is somehow actually good for the innovation and creativity process of startups. So I guess that's it for me. So I'll be handing the mic over to my colleague.
All right, thank you, Ahmed, for the great insights. I will now pass the floor to Ahmed Hussein to talk us through a bit more about the field. Ahmed, we can't hear you.
Can you hear me now?
Yes.
Thank you. I graduated from Cairo University, Faculty of Engineering, with a bachelor's in electrical engineering, and I'm currently a master's student at Nile University, which is a research university here in Egypt with a focus on big data and data science. I started out at IBM Egypt as an infrastructure engineer. And then I learned about the future of big data and data science analytics and its impact on business. So I kind of switched careers in 2017 to data science and analytics. I started out at a local analytics firm called Data Plus Information Systems. Then I moved to the big data analytics at Vodafone, and I'm currently working at Halen as a data scientist from March 2020 until now. So I will be discussing some actual topics that you need to understand and that you need to master in order to get you started in the field of data science, and then some advanced topics that you need to learn about later on as you go further. And if you discover that this is a thing for you, I will also talk about some skills that you need to have that are not necessarily data science related, but they will definitely make your life easier in terms of productionizing your code and working with your colleagues. And then I'm going to leave you with some fine prints, let me say, or some things that you need to be aware of when you're working in the field of data science, so that you have a complete picture. So in order to get started, you need to have a very good hold of the fundamentals of mathematics, linear algebra, and statistics. Most importantly, things like optimization, things like objective function optimization, things like matrix operations, statistics, of course, basic statistics and inferential statistics as well. Then you should move into machine learning fundamentals, know about classification versus clustering versus supervised and non-supervised learning. You should be able to understand how different machine learning algorithms work, like logistic regression, like support vector machines, like tree-based classifiers, for example. Then you should take very good care in learning SQL. SQL is a very important tool for the data scientist because this is where you get your data from, and this is how you extract the data that you work with. Usually in courses and in competitions like Kaggle, which is a very good platform for practicing data science, actually. but you don't get to do SQL queries to get your data. So people think that you will always get your data in a clean matter, in a CSV file or an Excel file, and that you will start working in your magic right away, which is not the truth. You will spend a lot of time querying your data with SQL. You will spend a lot of time wrangling and cleaning your data with either Python or R, which are the two most famous languages for data science. And actually, one of the earliest questions you will ask yourself is, should I learn Python or should I learn R? Now, this is a very heated debate in the data science world. I personally prefer Python. I wrote in both Python and R. I prefer Python for a lot of reasons. It's easier to integrate into production systems. A lot of libraries like TensorFlow and Keras are easier to work with in Python. But still, R has its loyal fan base. So I'm telling you my preference. I will leave that to you to discover. But my advice is definitely start with one and switch to the other, regardless, and then you will find your preference. You should also focus on data visualization, which is how do you present and how do you explore the data sets that you work with, which is also a very important skill, because a very good portion of data scientists' work is communicating with his business counterparts and stakeholders. Like Ahmed Mansour said, a business stakeholder will come to you and ask you, well, we want to analyze our churn. So if you develop a model and you want to present your results and you want to present your findings to your business stakeholders and counterparts, you will have to use visual aids and data visualizations in order to communicate those findings and those results. And finally, you should practice. This is not, don't get tempted by trying to learn all the theoretical parts before practicing. Yes, you should start learning. Yes, you should get a good hold of the fundamentals, but you should also should practice on example data sets and solve example problems like in Kaggle. And later on, you could also start doing some freelance jobs on freelance platforms. This is a very good place to also earn some money while you're practicing data science. Then when you've mastered all this, or when you get a good hold of all of this, you will have, by then you will have realized whether this is a thing for you or not, because at the end of the day, this is a career option. You could have other career options. So if you're comfortable with all of this, if you are if you don't have a problem with learning these things, then you're probably good to go. You should move into more advanced topics like deep learning and neural networks, like natural language processing and computer vision, recommender systems, social network analysis, time series and forecasting. These are pretty rather advanced topics, but also most data scientists work with them a lot. You should read into big data analytics using Spark, especially at the beginning. You don't not all places use Spark for analyzing their data sets. Only places with very large or diverse data sets that use Spark. So it's not a necessity, but it's also very well to have, because more and more places are using Spark, and it's also getting easier and easier to work with Spark these days. Back in 2014 and 2015, you had to write these long MapReduce jobs in order to parallelize your code, and then Spark came along, Spark 1.0. He was using something called RDDs, which were very difficult data structures. You had to practice a lot and wrap your head around them. Then Spark 2.0 came, and you can now use data frames, which are very similar to normal Python data wrangling with a library called Pandas. So it's getting easier and easier these days with a lot of abstractions presented by the Spark maintainers. So the barrier to entry is becoming less and less there. Also, you should keep practicing all the time. Never stop practicing. Even when you're working, you should practice on Kaggle from time to time, or any other platform, because it's a muscle. At the end of the day, you have to keep it. You have to keep it practicing. Now, these are some skills that are not necessarily data science related, but they will definitely make your life easier when you're working as a data scientist. You should learn about Docker and Dockerization, because most probably you will deploy your models on Docker environments. You should learn Linux, because you will be dealing with cloud platforms, and you will be using Linux as well with Docker. You should use Git. You should learn Git, because you're probably not working alone. You will be collaborating with other data scientists. You will be collaborating with other engineers in order to deploy your code into production, or deploy your models into production, and maintain them and scale them. Also, you should learn SQL tuning, which is how to make your SQL queries more performant and more and faster and less resource exhaustive, because granted, data scientists are not supposed to write a perfect SQL tuned code. They're not BI engineers or database administrators, but the more tuned and the better performant your SQL code is, better the life of everyone. So you don't become headache for the data engineering and the database administrators all the time. And you should be very familiar with at least one cloud platform and with its data offerings. Google Cloud Platform also is a very good example, since this is a Google event. But at the end of the day, you will work with the cloud platform your company is working with, but you should also. But most of them nowadays are pretty parallel to each other. So if you're familiar with one, you will find yourself able to deal with any of the others. But you need to be aware of the concepts of working with data in a cloud environment, because it's very different than working on an on-premise environment where everything is in a local data center. And these are the things that, unfortunately, they're very hard to learn on your own. You will have to get an internship or an entry-level position in order to learn them, but they're very essential for a data scientist. Things like domain knowledge and the business knowledge, and then being able to map or to connect between this business knowledge and the data sets that you have. So you should be able to map that this field in this table is because this promo code has to be sent every week, for example. So you will be the go-to guy, or you should be one of the best people to be able to link between the business knowledge and the business acumen that you've created, and the data sets that you have in the company. Working with real data sets is also something very different than practice problems. Because problems, usually the data that you are presented with is consistent. It's usually cleaned. It's enough to solve the problem because the people who made the competition, they know the data that you need, and they've probably solved the problem before you. But in the real world, you're presented with everything that the company, every data column that the company has. And you might need some data points to solve the problem. You might need all the data points to solve the problem. And you might realize that you don't have the right data points to solve the problem that you have. So this is a very different paradigm than practice, which is realizing the fact that things are not all sunshine and rainbows. You need to make sure that your data that you have, that the data you have can solve the problem or the question we're asking. Also translate questions or problems into a data science problem. This is also something very critical, and usually you get to learn it while you're on the job, because no one will tell you, hey, we want to build a classifier or a regression model to predict churn. Someone will tell you, well, we have a churn problem, what can we do about it? Because they're not data scientists. So you understand the problem, you understand, well, how do you want to act on it? Do you want to be proactive, or you just do, or you just want to know the drivers for churn, what's happening, and that would be enough for you. So you need to translate the business problem into a classification, into a regression, into a clustering, into a basic exploratory data analysis, where you're just doing deep dives in order to understand why this is happening. And this will tell you this because this is your role. Your role is to understand the business problem and translate it. Also, communicating with business stakeholders. And I have a quote for this. You should know what keeps your business stakeholders up at night. What is their number one KPI that keeps them? Is it that keeps them concerned? Is it churn? Is it conversion? Is it revenue? Is it burn? So you should be aware of the company's strategy. You should be aware where the company is headed. You should be aware of the KPIs and metrics that your business stakeholders are keeping track of. So this is not necessarily a software engineer's concern, for example. A software engineer in the same company wouldn't be concerned that we're up on churn 12% or 5% month over month, because he is more into creating the features and creating the back end and the front end for the users. But he wouldn't be concerned with the business metrics and the business KPIs, like you should be aware of, and you should use these to prioritize and formulate your data science projects. And finally, I'm gonna leave you with some points that you need to make peace with as a data scientist, or you need to realize. The first one is that data science is probably not the sexiest job in the 21st century. I'm referring to a very famous Harvard Business Review article that came out in 2012 that says that data science is the sexiest job in the 21st century. The authors were referring to the fact that data scientist is a very rare or a very scarce profession. The professionals who work in this field are very few. That was back in 2012, which is like 9 or 10 years ago, almost a decade. So they were saying that these data scientists are very important to the business, and there are very few of them. So there is a lot more demand than supply, like Ahmed Mansour explained. And this is still the case today, because the data is growing faster than the supply. So the demand is still higher. But I wouldn't go for saying it's the sexiest job of the 21st century. I think these are just flashing headlines, but still it's a very rewarding profession and a very rewarding career. The second thing is that you will spend more time cleaning and understanding the data points and communicating results with your stakeholders, more than the interesting part, or what we call the juicy part, which is modeling and predicting and and tuning models, which is usually what we like most as data scientists. The final thing is that you need to make peace with the fact that you're not the decision maker. Your opinion, or you are representing what the data says, but there are a lot of other aspects that the decision maker should look at before making the final decision. So let's say, for example, I'll give you a very clear example. Let's say at Halan, we want to look at areas we should expand into our ride-hailing business and areas we should not pursue or not expand in because of they're not very profitable or there's not a very addressable market. So the data should say you should expand in areas X and Y and stop expanding in area Z. But on the ground, the business might realize that, well, this area, although the data says it's not very promising, I know that there is an upcoming project that will create a lot of jobs in this area, so there will be a lot of demand. I have a strategic competitor that is expanding in this area, and I cannot leave him monopolize this area all by himself. Or that this area is very important for driving growth in other areas. So you're saying what the data says, but you're not saying you're not giving you're not you don't have the whole picture. You just have the picture from the data perspective. So you should live with the fact that your CEO or the company might go in a direction. Well, actually, it could be quite the opposite of what the data says, and you need to make peace with that. And you need to realize that not every time people will act based on your insights. Sometimes there are other aspects to cater for. But at the end of the day, I think driving value through data is the most satisfying feeling you will get as a data scientist. Whether through its models, whether through through insights, whether through its even a basic pie chart or a dashboard that puts a problem that we're having in business into a context. And I believe my time is up. So if anybody has any questions.
Thank you, Ahmed. It was very insightful. Really enjoyed the talk. I think we're down in time. So if anybody has any questions, they can always email me and I'll relay the questions to you, Mustafa and Ahmed Mansour. But other than that, thank you very, very much. It was a very insightful talk. And we'll have it posted on YouTube. Again, thank you for joining us today. Thanks for everybody that came. And see you soon, hopefully.
Thank you.
All right. Bye-bye. Thank you.